Let's talk about the types of variation and how do you write the variation statements. Critical in understanding variation is on the identification of the proper variables. That is why this practice, a pre-break session, is prepared for us to determine first which type of variation most probably these items do belong, and then later on come up with a variation statement. We have here four items. One and two has number one has two specific variables. Number two is a formula for the volume of the cone. Number three is a table, and number four is a graph. Our goal here is to determine which type of variation first all of this represents, and then later on come up with a variation statement that could explain how this works. So let's start with expenditures and savings. Or the other term for expenditures is expenses. Okay. So if we talk about expenses and savings, generally, the more you spend, the less savings you have. Generally, we're talking about the general or commonly what that's happening. And if we're going to say expenses may give us a bit of the chance, a greater chance for us to have a better savings. So the number or the weight for the expenses or expenditures and savings go in opposite direction. So for number one, this is an example of an inverse variation. Again, inverse variation because one goes up, the other goes down, and the other way around as well. But the problem here is to how to come up with the proper variation statement. When you say variation statement, we're going to come up with a sentence form that is explaining to us what is the relationship between expenditures in savings in terms of the type of variation it represents. Expenditures commonly, most commonly, I know that there would someone who would like, or a group of people who would like to debate that it should saving should start first before expenditures. But most commonly, generally, in a household, expenditures come in first before savings. Generally, I'm talking about the general aspect, not the ideal, the real aspect. Okay, the expenditures predict or tell us the savings. So the key in identifying the variation statement is to determine which variable is independent and which is dependent. Okay, in this case, commonly, generally, savings is dependent, or the variable for savings is dependent on your expenses. That would mean savings here is our y variable as it depends on the expenditures, and this is your x. When you come up with a variation statement specifically for inverse variation, you have two different options. Number one, you could state it like y varies inversely as x. And number two, you may say y is the inversely proportional to x. We have identified already here the general, most commonly, and the real form of the variables. So we can just simply say now that savings is inversely proportional, or let's just use the other term, varies inversely as expenditures. The first variable that we have placed here is your dependent variable. Again, I'm just stating the general and the most real scenario wherein savings is dependent on our expenditures. I know that there are also debate that we could also say that expenditure should be the dependent, but generally it looks like this. So that's the first possible statement, and the other statement would be savings is inversely proportional to expenditures. Let's proceed to number two. Number two talks about the volume of the cone. When you look at the given, it's we cannot determine immediately the variables representing the situation. We need to analyze first what are the variables or what are the variables present in determining the volume of the cone. The volume of the cone is given as 1/3 pi r squared h. Pi r squared h. All right. Again, the volume of the cone is 1/3 pi r squared h. When you look at this, you might notice here that there are plenty of variables that will detect or predict the volume of the cone. And those are actually r, and then h, and then v. Okay, pi here is not a variable because is a constant that is approximately 3.14, but it's not really 3.14, approximately. So pi here, together with 1/3, can be your constant of proportionality for the volume of the cone. This is your k if we talk about the mathematical equation. So now that we have this, we could say that radius and height predicts the volume. Okay? So volume is our dependent variable and our radius and height are independent variable. So this is a type of a combined variation. Why combined? Because it is actually a combination of a direct square variation and a direct variation here. Okay, combined variation is a type of variation which combines either inverse, direct square, and then the joint variation. So this is a combined variation. How do we try to come up with its variation statement? Now for combined variation, unlike inverse, direct square, and direct variation, it's up to us to discuss and decide the type of variation the variable represents. So for this, we can say here that the volume of the cone being our dependent variable, okay, varies. You might say here, let's start with R, varies as sorry, varies directly as the square of the radius and the height. Let's say it like that. Okay? So varies directly because they are both on the same level. Wala tayong fractional form. So varies directly. However, if you have a statement like this, it might be misinterpreted that height is also being squared. Simply read it like this. Varies directly as the square of the radius and the height. So some might say the height is also being squared. So to avoid that problem, you can just simply try to revise this, okay? And you might say varies directly as the height and the square of the radius. Okay? So it's better like this. The volume of the cone varies directly as the height. Definitely this is under multiplication, so it's commutative. So we can always start with height and the square of the radius. Still directly as the square and as the square. Directly as the height and as the square of the radius. So it looks like that. When I talk about combined variation, it's up to us, it's up to you on how do you write the variation statements. You just need to examine and then make sure that the variation statement fits the given. For number 3 and number 4, we don't have specific variables. So we are given with x and y here. And for graph, definitely this is the x-axis and this is the y-axis. So y stands as y, x stands as x. The only thing that we need to determine here is what type of variation they represent. For number 3, let me copy here this table. In determining what type of variation when given a table, let's just try to examine the trend of the dependent variable. What is happening between the y values as we move constantly to the x values. So as you examine here, you might notice that from 6 to 12, you just simply added 6. From 2 to 12 to 18 is also 6, and is also 6 here. We have here a common difference. And this common difference tells us that this table is under the direct variation. Why? Because there is a common difference here. In case wherein there's no common difference, try to examine the second. And if there is also a second degree common difference here, that would mean it's a direct square variation. If it doesn't have any pattern, but the values of y, as the values of x increases, the values of y decreases, it goes the other way around, it may be a inverse variation. And I try to examine the values. But for number three is concerned, again, this is direct variation. And after that, we can now simply write the variation statement simply by using only x and y. And we can say that y varies directly as x. This is one possible statement for direct variation, or you can also say y is directly proportional to x. For graph, simply look at the trend of the line. If it goes up, they only have two possible options, the direct and the direct square, because as x increases, y increases as well. But for when it goes down, we can also have the inverse variation. For joint variation and combined variation, we don't have yet the table of values in the graph, because if we talk about joint and combined variation, they involve more than two independent variables. And if we're going to have a table of value for that in the graph, it may become a three-dimensional figure or three-dimensional system. So as of 4-year level, we don't have a specific identification for joint and combined variation when it comes to graph and table of values. So you're only stuck with direct, direct square, and inverse variation. As for number four, it goes up, the graph goes up as x increases, y also increases. So we are just down to two, direct or direct square variation. There is also a distinction between the two. Direct variation is a linear graph. Direct square variation is a parabolic graph. Parabolic meaning it's a curve, curvy. Since this is straight, this is also under direct variation. And we just simply copy this because they are just the same. Or let me use the other form. Y is directly proportional to x. This is the statement for number four. So again, the key in understanding this pre-break session and this lesson is to look at the variables that affect the other and simply make sure that when you come up with a variation statement, the dependent variable is what is written first, and then it is affected by etc. etc. independent variables. Thank you very much. Hopefully you have learned. Goodbye.